Europa Clipper will be in position to potentially receive ions transported by the solar wind towards the spacecraft at several hundred miles per second. This may be the first direct immersion in material from an interstellar object.
Right now, at this exact moment, NASA's Europa Clipper spacecraft is flying through the ion tail of 3I Atlas. Not near it, not around it, through it. Between October 30th and November 6th, a $5 billion spacecraft designed to study Jupiter's moon Europa is accidentally intercepting material from another star system. This has never happened before. Not with Oumuamua, not with Borisov. Never in human history have we directly sampled an interstellar object. Europa Clipper is equipped with a plasma instrument and magnetometer, exactly the tools needed to detect charged particles streaming from 3I Atlas at hundreds of kilometers per second. But there's a problem. NASA is shut down. The government funding impasse means most of the space agency is furloughed. Europa Clipper is in cruise mode, and nobody knows if the instruments were activated in time. We're in the middle of the most significant astronomical sampling event in history, and we might have missed it because of politics. This wasn't planned. When NASA launched Europa Clipper on October 14, 2024, its mission was singular: reach Jupiter's moon Europa by April 2030 and search for conditions suitable for life beneath its icy shell. Nobody was thinking about interstellar comets. Then, on July 1, 2025, astronomers in Chile discovered 3I Atlas. Within weeks, trajectory calculations revealed something extraordinary. Two researchers, Samuel Grant from the Finnish Meteorological Institute and Geraint Jones from ESA, ran computer simulations using software called Tailcatcher. Tailcatcher tracks solar wind packets and predicts where cometary ions will travel. The program can calculate the minimum miss distance between a spacecraft and the central axis of a comet's ion tail. What they found was stunning. Between October 30th and November 6th, Europa Clipper's path would intersect 3I Atlas's ion tail. The spacecraft would pass within 8 million kilometers of the tail's central axis. That sounds like a lot, but ion tails from active comets like 3I Atlas can extend for hundreds of millions of kilometers. The ions spread out across vast distances, carried by solar wind at several hundred kilometers per second. Europa Clipper doesn't need to be in the exact center. The particles will reach it. The paper, published on ArcSiv on October 15th and accepted by the research notes of the American Astronomical Society, laid out the opportunity. Europa Clipper will potentially be immersed within the ion tail of 3I Atlas, providing the opportunity to detect the signatures of an interstellar comet's ion tail. Characteristic changes to the solar wind are also expected to be observed. A magnetic draping structure associated with the comet may be identifiable. A magnetic draping structure. That's when a comet's atmosphere distorts the magnetic field carried by solar wind, creating a detectable signature that proves you're inside the tail. If Europa Clipper's magnetometer is on, it will see this. If the plasma instrument is active, it will directly detect ions ripped from 3I Atlas. Material from another star, captured by a NASA spacecraft by accident. Let me explain why this matters. Oumuamua, the first interstellar object discovered in 2017, was spotted on its way out of the solar system. By the time we realized what it was too late. We watched it leave. That's it. 2I Borisov, the second interstellar visitor in 2019, we observed from Earth. Telescopes captured images, spectrometers analyzed light reflected off its surface. But we never touched it. 3I Atlas is different. Europa Clipper isn't looking at it from millions of kilometers away. The spacecraft is flying through the ion tail. Ions are charged particles, atoms stripped of electrons by solar radiation. When 3I Atlas heats up near the sun, frozen gases sublimate directly from solid to gas. The solar wind ionizes these gases and carries them away in a long, invisible tail. That tail contains the chemical fingerprint of 3I Atlas. Water molecules, carbon dioxide, carbon monoxide, organic compounds. Whatever volatiles exist on the comet's surface, they're in that ion tail. If Europa Clipper's instruments are active, they can identify these molecules by their mass-to-charge ratio. The plasma analyzer can distinguish between solar wind ions and comet ions. How? Solar wind is dominated by helium. Comet ions are dominated by water-related molecules, H2O+, OH+, O+. The signatures are completely different. This is in situ sampling, direct measurement, not telescope observations filtered through Earth's atmosphere, not spectroscopy from millions of kilometers away. This is like holding out your hand and catching snowflakes from another star system. Europa Clipper's plasma instrument can measure ion composition, velocity, and density in real time. The magnetometer can detect the magnetic draping structure, the distortion in magnetic field that proves the spacecraft is immersed in cometary material. And here's the kicker. This data would reveal whether 3I Atlas's composition matches solar system comets or if it's chemically distinct. Proof of a different planetary formation environment around another star. We have a problem. On October 1st, the US government shut down. Budget impasse, political gridlock. NASA furloughed thousands of workers. Europa Clipper launched on October 14th, 2024, over a year ago. It's currently in cruise mode, traveling toward Jupiter. Not all instruments are active during cruise. The spacecraft conserves power, runs system checks, and coasts. The ion tail crossing window opened on October 30th. That's 29 days into the shutdown. Grant and Jones published their paper on October 15th, 16 days into the shutdown, urgently highlighting the opportunity. But who's reading scientific papers when NASA's doors are closed? Mission controllers would need to activate Europa Clipper's plasma instrument and magnetometer. They'd need to configure data collection. They'd need to coordinate observations with ESA's JUICE spacecraft, which is also observing 3I Atlas from the other side of the sun. But NASA Mission Control is operating on a skeleton crew. Only mission-critical operations continue, keeping spacecraft alive, maintaining communications, emergency troubleshooting. Is activating instruments to sample an interstellar comet's tail mission-critical for a Europa mission? Technically, no. The Jet Propulsion Laboratory in Pasadena manages Europa Clipper. JPL might have personnel available, but coordination between teams, data processing, real-time analysis, all uncertain. And here's what keeps me up at night. Europa Clipper has never done this before. The instruments haven't been tested in this configuration. The plasma analyzer was designed to study Jupiter's magnetosphere, not intersect comet ions. What if they activated the instruments but the settings are wrong? What if the data rate is too low? What if solar wind conditions don't cooperate? Drain Jones, co-author of the prediction paper, told Space.com, with favorable solar wind conditions, Europa Clipper has a rare opportunity to sample an interstellar object's tail. Favorable conditions. We're rolling the dice. The detection window closes on November 6th. If Europa Clipper collected data, we won't know immediately. The spacecraft stores observations on board and transmits them back to Earth during scheduled communication windows. Normal operations, the data might arrive in days. During a shutdown, could be weeks, could be longer. ESA's JUICE spacecraft is also observing 3I Atlas from the other side of the sun using cameras, spectrometers, and particle sensors. JUICE's data won't reach Earth until February 2026. Why? Because JUICE is traveling through the inner solar system where thermal conditions are extreme. The spacecraft uses its high-gain antenna as a heat shield. It can only transmit data slowly through its medium-gain antenna. So, even if JUICE captures something extraordinary, we're waiting 3 months to find out. Europa Clipper is our best shot at real-time confirmation, but only if NASA activated the instruments, only if the shutdown didn't prevent coordination, only if the solar wind cooperated, only if the plasma analyzer was configured correctly. Too many ifs. Here's the timeline for what we know. October 30th to November 6th, Europa Clipper crosses tail. November 2 and 25, JUICE observes 3I Atlas. December 19th, 3I Atlas closest to Earth, backup observation window. February 2026, JUICE data arrives. If Europa Clipper caught something, it could be the first direct evidence of interstellar material composition. If it didn't, we'll never get this chance again. 3I Atlas is leaving the solar system forever. Right now, while you're watching this, Europa Clipper might be detecting ions from 3I Atlas. Or it might be flying blind, instruments offline, while the most significant sampling opportunity in space exploration passes by unnoticed. We won't know for weeks, maybe longer. But here's what we do know. This is the first time in human history a spacecraft has been in position to directly sample material from another star system. And we might have missed it because of a government shutdown. Subscribe if you want updates the moment NASA releases the data, because if Europa Clipper caught something, if those instruments were on, we're about to learn what interstellar comets are made of. And that changes everything. Thanks for watching. The universe gave us a gift. Let's hope we didn't waste it.